Hi, I'm Snen, and this is my series on game development with Rust and Bevy. In today's video, I want to talk about one of the aspects of Bevy's architecture that I find particularly interesting, which is the schedule type. With Bevy's 0.11 update, which has been out for a little while now, schedules have become a much more visible part of their top-level API, whereas before it was more like an advanced under-the-hood feature. And I say that because Bevy now requires specifying a schedule whenever you attach a system to your application, which is pretty integral to the whole process. So it really is very much, front and center in the whole architecture. So what is a schedule? What schedules do you as a game developer need to know about? And why has Bevy promoted schedules to be sort of a first-class member of their public API? In today's video, I'm going to start by answering these questions and then continue by going over a demo that should show how powerful these tools can be, as well as how powerful, libraries that want to plug into Bevy to provide common features, how powerful those can be as well. So what is a schedule? In short, schedules are the containers that manage and run your systems. Inside a schedule are all the function pointers to the systems that need to be run by that schedule. And then there's also a little worker gremlin in there that handles executing all those systems. So that's why when you add a system, when you configure some system set or anything like that, Bevy now requires that you specify the schedule that should perform this behavior. Now, technically, this value I'm pointing to here isn't a schedule. It's actually a totally different type, and it's one that implements the ScheduleLabel trait. ScheduleLabel basically marks that type as an identifier type for a given schedule. So when you initialize a schedule on your application, Bevy will, it requires that you pass a schedule label, and then it'll sort of map that schedule label to the schedule that it generates for that type. So when you then add a schedule, you only have to pass in sort of the nice schedule label types, but the appropriate schedule is updated accordingly. One other distinction I want to briefly go over here is that schedules are very different from system sets. System sets and schedules might seem a little bit similar at first glance, since they both kind of vaguely refer to configuring and running systems. A system set is like sort of a category label, and it can be used to define groupings as well as ordering relationships between systems. But that all kind of happens inside of a schedule. So if you're running some schedule, that's going to be the thing that actually takes those, those sort of ordering relationships defined by the system sets and then applies them so that the systems actually get run in the appropriate order. Now, this type here, update, that I mentioned a moment ago, this is a schedule label that Bevy exports. It's basically the one you'll use most commonly for adding your systems to a Bevy application. Typically, when you construct one of Bevy's app types, if you use the new or the default methods, Bevy automatically attaches a small set of schedules that are helpful for running basically a default application. For almost all use cases, like I said a moment ago, you're going to use the update schedule to attach your own systems, but you might also use the startup schedule, which is useful for running some systems once on startup, as well as the fixed update schedule, which is helpful for running basically things within a fixed time step, though I would look at the docs for more information on that. And if you ever use the add state method to define like a states variable, whenever you call add state, Bevy actually adds additional schedules for transitions between those states. So you can then add a system to like on enter this particular state variant, and then whenever the state changes, you get to run your system in that schedule. There are a few other ones, but those are sort of the most common, the most common schedules. Any crates that define like basically plugins that are like useful libraries for end users, they might also rely on some other schedules that are sort of attached by Bevy. There's the first, pre-update, post-update, and last schedules, and they run in that order with update in the middle. Basically, they're sort of there as ways for plugin authors to attach logic at various points in the life cycle of the core game loop, with guarantees about how those things will be ordered with respect to user logic. The last thing that's useful to note here is that all of these schedules I just mentioned are actually run by a single sort of parent schedule called main. The main schedule is defined by the main schedule plugin, which is always attached by default whenever you use the app new or the app default constructors. That should serve as a reasonable high-level overview of what schedules are in Bevy and what purpose they serve, but why am I talking about them today, and how are they relevant to the work I've been doing beyond their sort of ubiquitous presence in my app logic? Well, if you remember from previous videos, I've mentioned a couple times so far that I've been working on building networking logic for Cricket Pong so that people can play it over the web. That was going really well, and I was using a custom schedule actually to sort of manage a certain few concerns within the, sort of the overall strategy. I thought it was really cool, and I wanted to, that's why I wanted to talk about it originally in what would have been last week's video. There's been a bit of delays since I ran into some critical issues with a dependency that I can't really work around, and it kind of rendered the whole thing like not showable in a video. So, and I also had people visiting and a few other things. So anyway, this video is a little late, but that's fine. What I wanted to do instead basically was try to build a demo that would show some of the same topics, some of the same ideas, and kind of show how you can use a custom schedule for a specific set of useful purposes and what the ramifications of that would look like. So that's what this video is. And for the rest of the video, we're going to go through that demo that I built, and it's relying on the Bevy XPBD crate. Bevy XPBD is a physics engine. It's built entirely natively to Bevy, so unlike Rapier, the physics engine I'm currently using in Cricket Pong, it doesn't require like synchronizing with some other backend to do all the physics calculations. It's actually using the ECS to do that stuff sort of more natively. There's some neat history there, and the developers behind it do, really great work. So I'll add some links below to like the tutorial that inspired it and a few other cool things that you should look at if you're interested. I'll also say I don't know exactly how it stacks up in terms of parity with Rapier. I know that this is still very much in development, so it's a brand new crate. So don't necessarily expect too much there, but I'm very excited for this project. To add physics into your game, once you've chosen the appropriate 2D or 3D variant of the crate and added it into your cargo.toml file, all you have to do is add the plugin group physics plugins to your app, which by default will process physics in the post update schedule, so that whatever you do in the update schedule, if you want to set some physics properties, what have you, the physics engine will be guaranteed to process that after the fact by default. But the cool thing here, and the reason I chose this crate for this conversation, is that they actually allow you to pass in a schedule label so that you can choose what schedule runs the physics, right? Which means you could pass in a custom defined one or whatever else, right? Whatever makes sense for your use case. In terms of like library maintenance, this is a neat concept in and of itself. Bevy plugin authors can define their logic in ways that let you control when that logic occurs without having to necessarily make you as a consumer deal with all of the complexity of a physics engine, right? That's really powerful. And I think it's sort of a really powerful fact about Bevy itself, that you can wield these really powerful and complex abstractions that are often required to build games without being bogged down too much by actually managing their internal complexity. So this window I have open here is an application, and it's running Bevy XPBD in a custom schedule. I've done this. I defined a type, my physics schedule, and I've derived the schedule label trait on it. And then when I instantiate physics plugins, I'm passing my custom schedule into that constructor. Now you can see I have this little eGUI window that I'm using the Bevy eGUI crate. And whenever I click forward, every tick in the update schedule, I have a system that is actually running this other custom schedule, which then allows me to execute the physics in sort of an imperative way. Now this required a little bit of extra configuration in order to make sure that sort of time steps are obeyed and that it doesn't do things like try to figure out how many ticks it needs to process or whether it should process a tick. So I set it to guarantee 1 tick per execution of the schedule. And then, it's kind of cool. I get this like imperative way of managing my code. So this is the system that actually executes my physics. What's happening here is in that eGUI window, I have a separate system that when I either click that play button or I hover the hover target, it increments the current value in the simulation time resource. And then for every time in that given tick, which should only ever really be one in this case, for every time that increment has happened, you see the world here runs the myPhysics schedule, and myPhysics schedule is the schedule that the physics plugins attached all the physics systems to. So that's why we see the box moving. If you're trying to perform physics in some sort of networked simulation, it's really important to be able to control when exactly ticks occur and understand, not only sort of maybe a fixed time step, but also being able to sort of make sure that clients and servers are able to process the physics state and actually execute ticks in sort of a very controlled way. The execute physics system that I showed just a moment ago is actually a special type of system called an exclusive system. And it's named that because it requires an exclusive reference to the world object, which means that Bevy no longer can parallelize this system with other systems because we're kind of, we have exclusive access to the whole world. Like we can't safely share references to data inside the world without betraying mutability rules. So these have some interesting properties, but it's kind of a requirement to run our schedule. So let's go ahead and see what this looks like in the profiler, because I actually want to show this feature as well. I'm following the Bevy profiling guide and using the Bevy trace Chrome feature to make this happen. I'll send some links in the description below to show how this works. And you can see here, so we've opened up the site where you upload your trace. You'll see that here there's this part where I've clicked a few times and now my systems are executing, and then here there's this part that I've hovered and so it's executing every tick. And then there at the end is the part where I started clicking again. So if we zoom in on just one of these executions, here we can see there's the main schedule running, and you can see all the other schedules running underneath it. There's post update, and here's our schedule. So it's the only real system in update. Oh, there's other systems, but it's the only expensive system in update, so it's taking up the most time. And this is our physics system. This is our execute physics, and it's running the myPhysics schedule, which the physics plugin group from Bevy XBBD knows that it has its system inside of it that when you run that schedule, it'll also run its internal schedules and run these other details. One thing that I'm actually surprised by here is that this isn't multi-threading at all. Schedules are actually the mechanism by which multi-threading occurs in Bevy. It's true that you gain immutable access to the world, so that means that any systems assigned to that schedule can actually be run in parallel with one another. I don't want to spend too much longer on this video, so I'll just link to some of the sort of places in code that are useful to look at if you're curious about how the little worker gremlin does its job, and how executors work and all that kind of stuff. But suffice it to say that there must be some reason they have this being single-threaded or something like that. So that's schedules and how to run custom schedules in your own systems. I'll say that obviously they do come with some drawbacks, so this isn't the perfect tool to reach for in every situation. In most situations when you need to deal with advanced system configuration, system sets will be sufficient, and using just typical system ordering constraints within your update schedule. But there are certain situations like when maybe you need to control how many times a certain set of systems execute within a given specific single execution of update, for example, or what have you. There are situations where schedules are the best tool around, and I think it's really, really powerful that Bevy offers them. I'll say as well that this video is specific to Bevy 0.11 and I'm sure some of these details will change. So if you're watching sometime in the future, definitely trust Bevy's docs over me. I'll be linking to a bunch of places below, so I'm sure you can look through the git blame or whatever else to learn about what's changed in the meanwhile. And they do keep a good change log for more, so feel free to look at those for specifics if necessary. I'm also still trying to figure out what the most interesting stuff to talk about is on this channel, whether that's more about game design ideas or more about Bevy internals and Bevy patterns. So if you like this topic, if you'd like more videos on these kind of advanced ways of using Bevy, please let me know below. I'm definitely interested to know what people think and what people are interested in discussing and hearing about. But that's me. Thanks for sticking around for the video if you've watched this long, and be sure to give a like and maybe subscribe if you're interested in seeing more content. I missed last week's video, just already mentioned all the stuff that was going on, and sort of having to pivot on what this video's topic was a bit of a challenge for me, but I am going to try to continue coming out with one a week. Next week's video is hopefully going to be more of a game design topic, as well as talking a little bit about the flexibility of ECS and sort of designing game rules. So I'm hoping that'll be a cool video. But anyway, that's it for now. Thanks so much for joining. Take care now. Bye.